Hi, I'm Scot Schultz. I'm from AMD. I'm a Senior Strategic Alliance Manager. I work pretty extensively with the HPC Advisory Council as well as the Director of Educational Outreach. Just real quick, I know I'm standing in the way between you and lunch, and that's never a good presentation spot, but I wanted to cover basically three things through this presentation. That's the launch of our new Interlagos processor, and then I want to talk and touch on some of the HPC ecosystem and developer resources that you might need to be aware of if you're a software engineer or you're optimizing code or taking a look at porting open source software and how to get the most performance out of the open source software. So there it goes. Okay, so I wanted to give you an overview of Interlagos, what is also known as Bulldozer. It's offered today currently on the 6000 and 4000 series platforms, which is the current platform for our 12-core product referred to as MagnaCore. It's a drop-in replacement on the 6200 side and is the world's first 16-core processor. On the 4000 series platforms, there's the 4200 series processors, and that's codenamed Valencia, and that's the world's lowest x86 power per core processor. We just announced these two products at Supercomputing on the 14th of November this year. And I'm not going to go into all of these, but just so that you realize the difference, you can scale up to a 4-socket server with the 6200 series processors. So just touching on the Bulldozer module technology, this is a complete redesign from the core up since the introduction of our processors in 2003. So it's been quite a long time since we've had a complete core redesign. You could take a look. There's hello. Where's the spotlight? How do I go back? Go back. There's both dedicated components and shared components, both at the chip level as well as at the module level. So you have two dedicated integer cores, and then a number of shared components, including the fetch, decode, and the floating point scheduler are shared at the module level, and then the L3 cache is shared at the chip level. So this is a complete different architecture as to what you would normally see for Shanghai or what is called MagnaCore. It is yet in the 6200. It is in an MCM package, right? So there's different NUMA domains, but just keeping in mind that the shared L3 cache is shared at the chip level. So we've introduced quite a few improved features in the IPC, new instructions, and I'll go into those in a minute. Many virtualization enhancements. So there's faster switching between virtual machines. Virtualization technology is one of the strongest technologies that are part of Opteron. So even further improvements there. And then I'll go into the shared floating point here. Okay, in just a minute. So we'll talk about the 256-bit floating point unit and what's new in Bulldozer as far as what the instructions are. The AMD unique instructions that I want to touch on here are what's called FMA4 and XOP. And with these new instructions are probably the key instructions to actually unlock the real underlying horsepower of the Bulldozer architecture. The floating point scheduler is capable of ganging the 228-bit floating point units into a 256-bit instruction, and that is what is referred to as FMA4. Once again, AMD Opteron is very much focused on driving down power. These are just some features. We're supporting low voltage DIMMs. We have introduced a new power state called C6 power state, and I'll touch on that in a minute. We'll touch on that now. So it's what's referred to as AMD Turbo Core technology, and with this new technology, it's completely transparent to the user. So there is no software that you need to program or be aware of. But with the base frequency, you're able to set the TDP headroom kind of like in through the BIOS settings, right? And so where there is headroom, you're able to actually get a core boost of anywhere from 300 to 500 megahertz. And then with max turbo boost, it's basically this scenario here, where you're not using all of the bulldozer modules. So when you're not using a module, then basically what we do is we gate down all the power, we shut off the clocks to that module, and allows the rest of the cores to ramp up in frequency, so you have more of the TDP headroom there. So you can get effectively up to an additional 1 gigahertz of performance when half the bulldozer modules are active. So I'll skip over this slide, but just touching on some of the bullets, and we're going to make these slides available, correct? So I can keep us on schedule. What I wanted to touch on here is the partnership ecosystem. Here's just a few of the HPC Software Alliance partnerships that we have in place. We work with most of the top industry ISVs and IHVs. We'll go into the optimization of your HPC applications. This is probably the key takeaway of what I wanted to bring to you today, and that is kind of how do you unlock the power of this new architectural design, and you do that through the use of three major things, basically the tools, the compilers, and the math libraries, etc. Right? So we'll go into what is called ACML. It's the AMD math libraries. There's a full implementation of level 1, 2, and 3 BLAS routines, LAPAC, as well as comprehensive FFTs, random number generators. And basically, this library is kind of a drop-in replacement if you're currently standardizer on the ICC tool chain and you're using MKL. You should be able to just relink into ACML to expose a lot of the FMA4 functionality within Bulldozer, which is the kind of which if you're not familiar with FMA4, it's fuse, multiply, add. So you basically can do like A plus B times C all in one instruction. Where the ACML 5.1 should be released later this month. So we'll go into this. Then I also wanted to touch on the Open64 compiler. So, AMD is very, very centric upon open standards. We had a discussion earlier around OpenCL. We support, OpenCL, OpenGL, and of course, here's another, tool, Open64. The Bulldozer compiler optimizations are enabled through both GCC and Open64 and whatnot with certain compiler flags. In this instance, it's the dash march equals BD-ver1. And this will unlock the compiler to support all of the new instructions and give you optimized code that support AVX and FMA4 as well as XOP. This slide here just touches on some of the relative improvements that you'd see. This is just one case, the Polyhedron 2011 benchmark. This is using Open64 and the Opteron 6272. And like I said, we also support GCC and the GCC ecosystem. So I'd always make sure if you're playing with Interlagos and you're not seeing the performance that you would probably expect, depending on what version of Linux you're on, you're going to get a different version of GCC. So if you're standardized on Linux 5.6 or 5.7, there's going to be a completely different tool set in that as opposed to what you would see in let's say RHEL 6. So as far as the compiler support summary, this is basically it. Probably if you're taking a look at Interlagos today, you'd want to standardize on 5 minutes? Okay. Are you hungry?
And it's 5.
So yeah, GCC, Microsoft Visual Studio, the Open64, PGI 11, all are going to support features in the Bulldozer architecture. The developer.amd.com is probably the most heavily used, and this is where the most of the information that it's going to be the latest, the greatest information as the OSs mature and this particular technology takes off, as well as OpenCL and all of our math libraries, etc. Point to developer.amd.com. And then I wanted to touch on the latest available Opteron clusters that we work together with the HPC Advisory Council. So if you want to kick the tires on the Interlagos Bulldozer technology, we're standing up 3 clusters with the HPC Advisory Council, both Dell as well as an AMD reference-based platform design. So you can double check and the performance based on what the platforms are. All 3 clusters, Scalad, are available today. Yes? Awesome. And then here's just some additional references. And like I said, these slides will be available on the HPC Advisory Council site. So I think that's probably my final slide. Did I get through 22 slides in about 10 minutes?
Or less.
Or less? Okay, thank you. I appreciate it.